Well, this is part 2, solutions to quiz. We got up to question 4, part D, before the screencasting software cut us off. So we'll just return to where we left off there. We found that the gradient of BC, based on the coordinates supplied for points B and C, is just 2/5. Because AD is parallel to BC, the gradient of AD is also 2/5. So the equation of AD is just that. Now in this we've had to use the coordinates of the point A. We don't know the coordinates of D at this stage, so simplifying this equation produces that. Now we need to solve this equation plus the other one from part C. And just to refresh our memories of the one from part C, it was 7x minus 53. So we just need to solve those two equations simultaneously. Now, to save a little bit of time here, in case we get chopped off again, the x is 8 and the y is 3. And therefore the point D has coordinates 8, 3. So we now come to the next section, which is the extended response. Part A. In part A, we're asked to find an expression for the cost C in terms of N for the deluxe option of the vehicle. So I'm going to use C and subscript it with a D for deluxe. So the cost C for deluxe vehicle is 42N, N being the number of days that the vehicle is hired, and 42 the daily rate of hire. In part 2 of part A, we're asked to find an expression for the cost C for the rough it option. So we'll use C subscript R for the cost of hiring the rough it vehicle. Well, that works out at $15 a day plus 25 cents a kilometre, and the kilometres are measured by X. That's part A. Part B. So in this one we're asked to find the maximum value that N, the number of days, can have if Natasha plans to travel a total distance of 600 kilometres. In this case, X is 600, and if we go to the rough it vehicle, the cost for the rough it would be 15N plus 0.25 times 600. So 150N plus 150. Now we require the cost of the deluxe to be less than the cost of the rough it. So how many days can we get out of this? Well, we've got 27 less than 150, so N is less than 5 5/9. Therefore, the maximum number of days will be 5, assuming, of course, that we have to work with whole days rather than fractions of a day. Questions would normally specify whether they will entitle you to use whole days or just all fractional components of a day. Now there's no clarity in this question about that, so we would assume that we're talking here of a maximum of 5 days, whole days, because there is no maximum for n less than 5 and 5 ninths if we were to allow n to be just any real number. So that's the end of the solutions. I hope that has made some sense to you.